Okay, so today we are going to be adding and multiplying matrices and figuring out the rules and how you do it. So here we have three different combinations of matrices: combination A, combination B, and combination C. And we're going to be figuring out if you can add each pair of matrices. So for the first pair, you have matrix A plus matrix B. So the first thing you want to do is figure out the dimensions of each matrix. So we have matrix A, and it has 2 rows. So it's a 2 by, if my pen will work, it's a 2 rows and 2 columns matrix. And it's very important that you start the dimensions with the rows when you're writing out the dimensions of the matrix. So 2 rows, which are left to right, by 2 columns, which are down, plus the matrix 5, -3, which is 1 row times 2 columns, which is down like that. So you have a 2 by 2 matrix and a 1 by 2 matrix, and you're trying to figure out what the solution of this is. However, when it comes to adding, you can only add matrices if they are the same dimensions. So these are not the same dimensions. You have a 2 by 2 and a 1 by 2 matrix. They're not the same dimensions, so you have no solution. Now let's look at the next pair of matrices. Actually, we can write out no solution because different dimensions, like that. So no solution because different dimensions. Now let's look at this next pair, A plus C. So we already established A was a 2 by 2 matrix, so we can write that down again. A is a 2 by 2 matrix, and matrix C is a 2 rows by 2 columns, is also a 2 by 2 matrix. So you can actually add these two matrices together because they are the same dimensions. And I can do something like that. They're not the same dimensions. These are the same dimensions, so you can add them together. Now, the way you add them together, you just add the numbers that correspond with each other in the matrix. So what I mean by that is these are both in the top left, 3 and -2. So you add those together to get the resultant matrix, the number that equals that matrix. This equals a 2 by 2 matrix for your answer. So you have, can write this out in math. So you have 3 plus -2 for that first one. Then you have -1 plus 4, -1 plus 4 for your second variable. Then you have 4 plus 7, and you have 2 plus 1 for your final variable. If you do all of those, you should get your matrix as 1, 3, 11, and 3 for the dimensions of your matrix. So this is a 2 by 2 matrix, just like these two, and you're just adding the numbers that correspond to each other in the matrix to get the answer. Now, final combination, B plus C. We already know the dimensions of B and C. B is a 1 by 2 matrix and C is a 2 by 2 matrix. Since the dimensions do not equal each other, there will be no solution because of the different dimensions. So from these examples, we can make a generalization for a rule that you cannot add two matrices unless the dimensions of each matrix are the same. So yeah, now that we have adding matrices done, let's look at how we multiply matrices. So again, we're using the same exact matrices, same exact combinations, except this time we're going to be multiplying them. So again, just like adding, very important first step is to write out the dimensions of each matrix you're working with. So as we established before, A is a 2 by 2 matrix, and B is a 1 by 2 matrix. So these are very, very important first step when figuring out to multiply. When you get these, and keeping the order is very important. You always want to take the dimensions of the first matrix and set it equal to the dimensions of the second matrix. So you have the rows and columns of the first, then you have rows and columns of the second. Now, the first thing you want to look at is if these two numbers on each side of the equal sign are equal to each other. If they are, then you will get a matrix with a solution. However, in this example, these numbers are not equal to each other, so this does not work. There is no solution because these numbers are not equal to each other. So let's look at the second example, A plus C. These are both 2 by 2 matrices. So when we set up the equation for the dimensions, you have a 2 rows times 2 columns. For the first one equals 2 rows and 2 columns for the second one. Now, first numbers you want to look at are the two next to the equal sign, and these numbers are equal to each other, which means that you will be able to multiply these matrices and get an answer. So how do you figure out the dimensions of that matrix? Well, you look at the two numbers you have left. There will be 2 rows and there will be 2 columns in the answer, because you take how many rows there are in the first matrix, 2, and the number of columns in the second matrix, 2, and that will give you the dimensions of the resulting matrix. So now comes the more complicated part. How do you solve for this? Well, you already know that it's going to be a 2 by 2 matrix, so we can just represent those with A, B, C, and D. So the way you solve for each of these numbers is you multiply the row that the number you're looking for is in and the column it is in for each matrix. So for A, you are going to be using the first row in the first matrix and the first column in the second matrix, because this is in the first row and the first column. So what you do is you add the first number in the first row by the first number in the first column, or multiply those, and then you add that solution to the second number in the first row and the second number in the first column. Now that may seem complicated, but if we write that down, it'll look a lot easier. So for A will equal the first row, the first number in the first column in the first row, multiplied by the first number in the first column of the second matrix, which is going to be 3 times -2. And then you're adding that with the solution to -1, the second number in the first row, by the second number in the second column of the second matrix. So -1 times 7. So you get 1 times 7. And when you add that, you will get the answer -6 plus -7, which equals -13. So A equals -13. All right. Now you kind of do the same thing for all of the others. I'm just going to write this up here for space. So B equals, it's still in the first row, so you're still using this first row, but it's in the second column, so now you're using the numbers from the second column. So 3 times 4. 3 times 4 plus -1 times 1. So -1 times 1, which equals 12, plus -1, which equals 11. Then you do the same thing for C. C is in the second row, so you use the second row of the first matrix, and it's in the first column, and so you use the first column of the second matrix. So 4 times -2 plus 2 times 7, and you get 2 times 7 equals negative 8 plus 14, which equals 6. So you get 6 for C, and last but not least, D. D is in the second row and the second column. So you're using the second row, second column. 4 times 4 is 16 plus 2 times 1. And you get 18. So this is your solution to A times C. Okay, now the last combination, B plus C. We already know the dimensions. So first thing, you want to write out the dimensions. This is a 1 by 2 matrix and a 2 by 2 matrix. So order, again, is very important when you're writing out the dimensions of the matrices. So you have a 1 by 2 matrix. So 1 row, 2 columns, and a 2 rows by 2 columns matrix. So here, the first thing we want to look at is these two numbers, and they are equal to each other. So that means we will have a solution for these matrices. Now, what is the dimensions for that matrix? Well, you look at these numbers now. The rows in the first matrix, you have 1 row, and the columns in the second matrix, 2 columns. So the resultant matrix will be a, the resultant matrix will be a, 1, if I can fix this real quick. The resultant, resultant matrix will be a 1 by 2 matrix. Okay, so now that we have the dimensions of our final matrix, we are going to be solving it very similarly to how we solved this matrix above. So A is in the first row, so we're going to be using the first row of numbers in the first matrix, and it is in the first column, so we're going to be using the first column in the second matrix. So similarly to the other one, we are just going to be adding the first, multiplying the first numbers and adding that to the solution of the second numbers. So 5 times negative 2, and you get 5 times negative 2 plus negative 3 times 7 plus negative 3 times 7, which equals negative 31. So A equals negative 31. B, now that we're looking at B, you will have, it's in the first row, so you're using the first row of the first matrix and the second column of the second matrix. So 5 times 4 plus negative 3 times 1, which equals 17. So the solution to this final matrix is negative 31, 17. So when multiplying matrices, it is very important that you first figure out the dimensions of each matrix, and you make sure that the numbers on each side of the equal sign are indeed equal to each other. If they are not, then you will have no solution. If they are, then you will be able to multiply using these rules that we went over to get the answer to the final matrix. Awesome. Thank you for watching this video. And well, make sure to like, make sure to subscribe, turn on the notifications, and yeah, stick around, and I'm sure there will be more videos just like this in the future.